Well, first of all, this screen you see right now is it's routed through my computer with the video capture, but it's actually the output coming from my Sega Mega Drive sitting on this side table, and this is a special cartridge that lets me run lets me run a bunch of different ROMs I want to run from an SD card. So, and I wrote my presentation tool, and this is the presentation tool. Let me start. So this is mruby Z, a minimal mruby VM for Zilog Z80 by Yuji, that's me, and press A to start. So let me do that. And now, about this app. This is a presentation app that I wrote that runs, it's running on Mega Drive, but it's actually a binary ROM written for Sega Master System. I'll explain a bit later, but Sega Mega Drive was a console from the 80s that's compatible with Master System, which was the target platform for this project. And I started on this presentation app calling it Demo 04, but now I'm unofficially calling it SMS Present, Sega Master System, SMS. And this is a live demo. So the fact that you can see this screen and I'm pressing the buttons and it's going forward is my live demo is succeeding. Thank you. And it's running on my mruby Z VM that I have mentioned in the title. I'll explain more about it soon. And so far, this presenter can only show text. And this is the sort of thing you're going to see through this session. And that I tried to do more, but haven't managed to implement any graphics. So, and again, who is this? And the person sitting and talking, this is Yuji, and I'm based in Tokyo, Japan. And you can find me on Fediverse at Yokoo at ruby.social if you are in the Fediverse. And I'm a programmer working at an Australian startup called CipherStash. And what's this project about? It's a minimal mruby VM for Z80, but well, I'll explain it again. It's running mruby bytecode on a VM for Zilog Z80. So now, after hearing this, I think I wouldn't be surprised if you went, what is mruby? What is bytecode? What is VM? What is Z80? And that's fair enough. I'll go explain those as well. And there's a URL, the source code for this project and presentation is available on on Codeberg. And I haven't made a release, but I will make a release tonight. And so to start with, I'd like to explain what mruby is. mruby is another implementation of Ruby. If you're not worrying about the implementation, you're probably using the canonical implementation CRuby. And there are other implementations like JRuby, which runs on JVM. And mruby is a smaller, more suited for embedded usage of Ruby and integrates well with C and, of course, other languages. And also, it's intended to be run in smaller environments, like hundreds of kilobytes of RAM is usually the target RAM size for mruby. And then what is a VM? You might be wondering. Well, VM is a virtual machine. It's a machine inside a machine or computer on a computer. And you might have a computer that has an Intel processor or ARM processor. Those are physical processors. And on top of that, you can make virtual machines, virtual computers that runs Ruby-specific instructions. And that's the Ruby VM. And you might not be aware of this, but when you run Ruby code like put s hello world, what happens is the interpreter is not actually executing that code directly. It's first compiled into bytecode. It's often called the intermediate representation, and then that is executed by the VM. And So the VM executes the bytecode instructions. And so what is bytecode? Again, VM instructions, but it's portable and not specific to any architecture. So it's not like or machine code for Intel or ARM. It's virtual instructions specific for Ruby in this case. And they're a lot simpler. Often a simple statement in Ruby gets compiled and expands into multiple steps. And I'm not going to go into the details, but CRuby is a VM is a stack machine, and mruby VM is a register machine. So as a result, a lot of operations on mruby bytecode is about registers. And if you're not aware, registers are like, if you have a physical processor, registers are tiny amount of memory locations, and that's very fast and built into the processor. So what your processor does is to fetch value from memory, operate on store in register and operate on the values, and then store back in the memory. That's the sort of stuff your physical processor does. And here, the mruby register machine does similar things. And I'll show you a little example of bytecode. Here you have a very simple Ruby code that is return 3 double equals 2. So this compares 3 with 2, and if because the result is false, it returns false. And when you compile into bytecode in mruby bytecode, it expands into something like this. Don't worry about the left 2 columns, but if you look at the right 3 columns, first line says load load the integer 3 into register 1. R1 is the right-hand side. And also the second line says load integer 2 into register 2. And then the third line says run equality operator between register 1 and register 2. And it's implicit, but this equality instruction overrides register 1 and stores that value into register 1. And return register 1 is the following line. So it expands into those steps when you have simple Ruby code like this. And so okay, now I can compile Ruby into mruby bytecode, but you might be wondering what I can do with it, and that's mrubyC, the bytecode compiler, can produce bytecode that's compatible with C in the form of C headers and C arrays. So it looks like this. It's just a bunch of hex numbers. Well, it doesn't have to be represented in hex, but it makes sense to use hex because they're bytes. And so your VM needs to load this into memory and execute that. And you can include this directly in your C source code and load it from your VM. And also, I'd like to mention mruby/C, which is a smaller footprint version of, more efficient version of mruby. It doesn't perform very well. As in it doesn't focus on performance, but it focuses on smaller footprint. So mruby/C runs in the memory space of usually dozens of kilobytes, and /C for compact or concurrent. And mruby/C was a big part of one of the reasons why having experience with that, having used that, is one of the reasons why I decided to make my own VM, mruby-Z. And also Z80. You might not be familiar with Z80. It was a popular processor from the 80s. It was actually first released in 1976, and it was manufactured into about 2024. So it had a long life, and it was very popular in the 80s. There are some 16-bit aspects like register size, like you can use 16-bit registers, but primarily 8-bit. And used for many popular platforms like Sega Master System, Sega Game Gear, Sinclair ZX Spectrum, and many, many more. And so specifically, I mentioned I targeted a Master System. So Master System was a Z80 console from Sega, and Z80 was the main CPU at 3.5 megahertz, and main RAM was 8 kilobytes, and address space was 64 kilobytes, and by default you could have up to 32 kilobytes of RAM, ROM, and there are clever tricks like bank switching, which lets you access more than that, but I don't even know exactly how that works. But you might not be familiar with the concept of ROM if you're dealing with modern computing environments. Typically, you have stored data on SSD or SD card or hard disk, and they have to be read into the memory first. But when you distribute ROM cartridges like old video games, what happens is you plug that into your memory bus directly next to your RAM. So what that means is the contents of ROM is accessible as memory locations. You can read from it without first loading into your RAM. But because it's ROM, read-only, you cannot write to it. That's the concept of ROM. And I initially found it weird because it's like storage, but it's directly available, and I can't write to it. So and also video RAM for Master System is 16 kilobytes, and it's fully tile-based, and the resolution is 256 pixels times 192. So that's why you see what you see. This screen a bit pixelated, but I can't go any finer than this. And as I said, Mega Drive has. Well, you might have thought Mega Drive is a 16-bit system that features a Motorola 68000, and how is it 8-bit? Yeah, you're right. But yes, Mega Drive features Z80 running at 3.5 megahertz as well, and that is typically used for sound processing. But there's pretty much full compatibility with Master System on the Mega Drive using that Z80 as the main processor. And so again, what is this project about? Back to this slide. This is not a bug. Running mruby bytecode on a VM for Zilog Z80. So hopefully I explained these words reasonably in detail so that you can get what this really means. And also, what I'd like to explain what I mean by minimal VM. A minimal VM is a program that reads and executes bytecode, a very small subset of it. And I did not do anything focused on performance, so it doesn't perform very well. And also, you might be wondering, there's mruby VM and mruby/cvm, and why would I write my own? Initially, I wanted to run somehow wanted to run mruby code on Z80, but mruby/c couldn't be built because, well, it's not impossible, but mruby/c uses a lot of C99 features, and there is no GCC or Clang targeting Z80. So what that means is the compilers are very old. Actually, they're actively being developed, and those compilers actually have decent compatibility with more modern C features, but there was going to be a lot of modification to a lot of C code that I would need to do, which would introduce a lot of bugs, and I wasn't even sure what the semantics of those things were. So rather than starting with a big project and modifying heaps and possibly introducing so many bugs that I don't even know exist, I decided to start from zero, fewer bugs, fewer features. So I started developing my own VM. And you might be wondering if this is the first project that brings mruby to the 8-bit world, and that is absolutely not the case. There's something called micro mruby from quite a few years ago. This was someone who ported mruby/c to Arduino Uno with Atmel AVR 8-bit CPU plus 2 kilobytes of RAM. And also NES Ruby, this was a work from a couple of years ago, I think, and this was someone developing mruby VM that runs on Nintendo Entertainment System, which runs 6502, another 8-bit processor plus 2 kilobytes of RAM. And this was also really inspiring for me to see this working. But those two projects with 2 kilobytes of RAM had a lot of limitations. It's compared to the Master System has got 8 kilobytes, which is 4 times as big. So there's a lot more I can do with a Master System. And also there's an interesting project called Ruby Game Boy. This is this author of this project saw that I started on mruby Z and used a very similar approach to target Game Boy. And this is quite impressive. There's a working snake game as well. And so what are the features of my VM? You might be thinking. And it has got built-in functions, but there is absolutely no user-definable functions. So there are things like puts that I have directly built into the VM, but there is no way to supply standard library or define your own function. And assignments like a = 1, that's supported. And strings, as you see text on this screen, these are actually strings internally in mruby. And also integer operations are supported, but there's no float support. And if-else branching, and also while loop is the only form of loop supported. There's no other form of loop, and there's no looping through enumerator with each either. And equality comparison, greater than comparison. And also you can define array and you can access array. You can modify arrays and many more features. So then what is not supported, you might be wondering? Most things are not supported. Well, as I said, there was greater than supported, but less than is not supported. What this means is you have to swap the order of the comparison, or if you want to do a greater than or equal to, that's not supported either. So you have to split them into greater than or equals as separate comparison steps. And also there's no garbage collection. And I've been trying to minimize support for features that require memory allocation. So eventually I will add garbage collection, but so far and absolutely no garbage collection. And also, string manipulation is not supported. So what that means is like you cannot use interpolation with hash braces because that would require building a new text data, which means allocating memory. So instead, all strings are contain fixed text data, but that way all the text data stays in the ROM, does not need to be allocated in RAM. And exceptions aren't supported. So whenever it sees something not supported in this VM, it just exits with an error message. And, unsupported. Yeah, this is what you get. This is the right time, yes, right on time. Except this was actually me just displaying the error message as a presentation content. It didn't actually crash. Okay, and classes aren't supported in my VM, procs aren't supported, and function definitions aren't supported, but it's underway. I've started working on function definitions. It will work soon, but function definition and function invocation are separate features, so you can, soon I'll be able to define functions and have no way of calling them. And lots more things. As I said, most things aren't supported. Guess what? Fiber, threads, eval, no way. So what can be written, you might be wondering, with this limited VM? Well, this presentation tool is actually running on my VM. And actually, I used a real mruby compiler into bytecode. And this is not what the code looks like, but initially it started with something like this. So it defines index and it uses while loop, because while is the only form of loop supported, and there is no each. So and also there's greater than. There's no less than isn't supported. So it has to be greater than. And also button A pressed and put S. Those are built-in functions. And pages I, because there is no each, I have to use subscript like index to access array elements. But this is how this is sort of how this presentation tool started. It does a lot more, and also it's quite verbose and repetitive because there is no way to organize the code into functions. But it is working okay, I guess. And the development process was like write some Ruby and generate bytecode, load it on my VM and run, and see it exit with an error message, and add support, or more important, implement support for that feature, or more importantly, give up and find a way work around, or just decide not to support such features and forget about it. And the limitations and challenges I encountered, well, memory limitation was a really big one. So I did a lot of stuff. I postponed support for features that need memory allocation. And also because I think partly because it's such a old processor with lots of things happening, I haven't been able to find very good source of very comprehensive and documentation collection. So it seems a bit scattered. And also, there's no native 32-bit support, and unfortunately, mruby compiler is assuming the platform supports 32-bit integers. And as a result, my VM, whenever it sees 32-bit numbers, it just ignores the upper 2 bytes and just hopes for the best. But if you're writing programs for such a small environment, I think that's reasonable too. And also another thing is, whenever I see weird behavior, I don't know whether it's a bug in my app code or bug in the VM, and the investigation can sometimes get tricky. And also, it's slow. It's not really good for action games, but it's not unusable. As you can see, I can successfully run this presentation. And I would like to conclude this session with a demo game, or maybe because I have to turn off this presentation and go into the demo game program. Before that, I would like to share the summary of this presentation with you. Summary: even a small subset of Ruby can be used to write useful apps. But useful is, it depends on your perspective. And but yeah, this presentation, I would argue this presentation app is useful. And also conscious decisions about what not to support is quite important. And writing your own VM isn't that hard. Just start writing a bytecode parser and start executing instructions, and now you have a minimal VM. And also, what is VM may be loosely defined. It might be just it might be just a tiny interpreter, but I think it's fair to call that VM too. And so you can make any platform support mruby by making your own VM if you have access to developer tools. So if you think, this watch from I bought from China has got some SDK, but there's no Ruby support. Well, maybe you can. So go make your own VM, or if VM is not your thing, please make whatever you want. And please never mind the trend, and make things you enjoy. And thanks to people who made awesome software, and thanks to RubyConf Thailand for giving this opportunity. And I'd like to conclude this with a demo game. So let me restart this presentation. Restart Mega Drive and select the demo game. So demo 04 was a presentation. And in fact, I had a dark background here. And I used the alternative version white background. And demo 05, this is a dark background, so it may not be as easy to see. I guess you could see this game. This is a game I wanted to develop further, but kind of ran out of time. It's player is the green A, and it's trying to shoot down red V. And the idea was the red V would shoot back, but I haven't implemented that. So it's kind of one-sided violence from green person. So, but yeah, okay, that's gonna hit. Oh, oops, no. Okay, so I also prepared a special attack. Yeah, take that. Thank you very much. That's mruby on Z80.